Hello. So in this video, we are going to be talking about the transformations and in particular the analytic view. So we're going to be covering the sort of algebra involved. So if you remember transformations, right, when we talked about the geometric view, we had that bit about how it sort of stretches stuff, right? So the transformations are when we can stretch stuff either sort of horizontally or vertically, and we can do that sort of flipping thing, right? Flip it over one of the axes or the other. So we're going to talk about now how to tell how much it stretched and whether or not it flipped, etc. As is sort of usually the case when we go through these translations, transformations, all of these things, we can split this up into the X stuff and the Y stuff. So in this case, the vertical transformations, meaning that when we stretch stuff vertically, we're going to be dealing with Y stuff, and the horizontal transformations, meaning when we stretch stuff horizontally, we're going to be dealing with X stuff. All right, so X stuff, right, the horizontal transformations, that targets the independent variable, that X stuff, as it says. Likewise, vertical transformations, that targets the dependent variable, the Y stuff, as it says. But when we say that it targets these things, what we mean is where these things come into play. So transformations, right, we mentioned at one point how transformations are sort of like doubling the space, right? When we stretch it, like each point gets twice as far away. So that's exactly what's happening here. This A that I'm multiplying by, that's the stretching factor in some sense, which, you know, that's the whole point of this video. We're going to figure out what sense that is. So here, when we targeted the X stuff, the way you can tell it's a transformation is because we're multiplying by some number. Same with the vertical bit, right? The Y stuff happens after the F, so the B is outside that's being multiplied, right? So here, this is the Y stuff because it's outside the F of X. Here, because I'm multiplying by something inside the parentheses for the F of X, that's how you know it's the X stuff. So, Y stuff. Well, the Y stuff works pretty much as we would expect. If I multiply by something that is quote-unquote large, meaning that I multiply by something that is bigger than 1, the graph stretches or gets bigger, right? If the B that I'm multiplying by is small, right? If I multiply by like 1/2, the graph shrinks, it gets smaller. It's basically working exactly how you'd think. So let's look at an example. So let's say we have this sort of nice unit circle, which that phrase may bring back nightmares. Don't worry, we're not going to use angles here. So if we multiply by a big thing, right? If I multiply by B that is bigger than 1, say 2, it gets stretched to be twice as tall. Notice that it doesn't multiply all of the points because this is just the Y stuff. It's only in the Y direction that I'm multiplying, right? Likewise, if I start at my sort of normal unit circle again, and I multiply by something small, like let's say B is 1/2, then I get half the size, right? I shrink down by a factor of 2, or I am half as big. And again, notice that this is still only the Y direction, right? Because this is only the Y stuff since it's multiplying outside. So if I multiply outside by, say, 1/2, I get 1/2 as tall in both like senses, right? The positive is half as big, negative is half as big, so it's closer to 0. But the X direction is pretty much untouched. Okay, so nice little sort of summary here. If I start with just a nice little circle, multiply by a bigger number, it stretches and gets bigger, right? I get an oval that is sort of stretched out in the Y direction. If I multiply by something smaller, I get something that is sort of squished in the Y direction. So it makes it sort of look like it's a horizontal oval. Technically it is, but notice that the X value, right, the width stayed the same in all 3 pictures, right? It's always a width from -1 to 1. It's just that the height is changing. All right, so X stuff. Well, this thing works as expected almost, right? It's not quite what we want because these things are flipping, meaning that if I multiply by a big number, the graph actually shrinks, it gets smaller. And if I multiply by a smaller number, the graph actually gets bigger. So as an example, if I have here, right, my unit circle, I'm just affecting the X stuff, right? So I expect the left-right to be the thing that sort of stretches or shrinks. If I multiply by a value bigger than 1, say 2, it shrinks by a factor of 2. So one of the ways of interpreting this, if you're sort of a more visual kind of person, is that it runs through the x values twice as fast. So it only has to go out half as far to get all of the values that used to be there. This has to do more with a calculus interpretation, so if that doesn't work for you, don't worry about it. Rule of thumb is that when you're multiplying by a bigger number, it shrinks by that factor, so it gets sort of 1 over that number of the original size. So if I multiply by 2, it's going to get 1 over 2, or half the size. If I multiply by 3, it'll get 1 over 3, or a third of the size. Conversely, starting with my unit circle, if I multiply by a small number, it actually gets bigger. It takes longer, more x numbers to go through the same sort of original values. So here, it's sort of the same deal, but with the fraction thrown in. So if I am multiplying by, say, 1/2, then the actual effect is going to be 1 over 1/2, or twice as wide, right? So when it comes to x stuff, the amount that it changes is 1 over the number that you would sort of expect, right? So if you're multiplying by 2, it's half the size. If you're multiplying by 1/5, it's 1 over 1/5, or 5 times the original size. Okay, and here's our nice little summary. So, right, if I multiply by 5, it would be 1/5 the size, so it shrinks. If I multiply by 1/10, it would be 1 over 1/10, which is 10, so it gets much bigger, right? So same idea, but the opposite. In other words, everything about x is backwards, right? That's our mantra for translations and transformations. It sort of works, except it's backwards for everything, whether it's moving left, right, moving sort of stretching left, right. All of these things are always backwards. All right, what about the negatives? We said that negatives involve flipping the thing. So for y stuff, we are flipping vertically, which when we think about it is actually the x-axis. So this usually throws people because it's y stuff, x-axis. But when we look at flipping over the x-axis, what that means is that when I flip this, all of the y values switch, right? So flipping over the x-axis really means that sort of values up here flip over the x-axis and end up down here. So over the x-axis is indeed a vertical flip, right? This is the one time where x stuff does what you would expect. X negatives, multiplying by negative, flips horizontally. Again, sort of because of the way that it sort of works out, this is a y-axis. It flips over the y-axis, but that really is an x flip, right? Because if I have the y-axis here, and I look at the value over here, and I flip over this axis, I end up over here, but that's flipping horizontally like that. What did we do? Well, we talked about the analytic view for the transformations, right? So this is the stretching and flipping. The sort of good news is all of the y stuff works exactly how you'd expect. Multiply by a big number, gets bigger. Multiply by a small number, gets smaller. The good news is that x is consistently not how you'd expect it, right? Everything about x is backward. So the actual change is sort of 1 over the number, meaning that if you multiply by 5, it doesn't get bigger, it gets 1 over 5, or 1/5 the size, it gets smaller. But if we multiply by a small number, it doesn't get smaller, it gets 1 over that. So if we multiply by 1/3, it gets 1 over 1/3, or 3 times bigger. So multiplying by small numbers gets bigger, multiplying by big numbers gets smaller, right? So everything about x is backwards. With the exception, because of course there's exceptions, but with the exceptions of negatives, right? Negatives always work the way you'd expect, a flip. The axis they flip over is sort of counterintuitive until you think about it for a minute, because if we want to go sort of horizontal flipping, that's flipping over the y value, right? So x stuff being negative flips over the y value, the y-axis, because that's flipping the x values. Likewise, if I want to flip the y values, that's flipping over the x-axis, right? So a negative on the outside, a negative for the y stuff, that's going to be flipping the thing over the x-axis, because that really is flipping the y values. Okay, so that is that.